Hi everyone. Uh, I have to. I'm gonna just turn video for a second, and then we'll start. Okay? And pause recording. I uh, I went to college, and I didn't realize that it wasn't open today. So I hope no one else wasted their time like me. Okay, just stop. Okay. Anyhow, they went to the college, and turned out that. I just have to close my things open. And let's see what else do I have open. Uh, let's make sure everything is closed. Push on my desktop. Um, okay. Yeah, they're closed. Okay. Well, sort of closed. We're on Zoom. So the bad old days of Zoom. Okay, so let's share. And let's go here and here. And I hope somebody was going to be available to present on Thursday, okay? Because we need a little bit presentations to keep going. Okay, so first, actually, let's look up and see what is um the deal with our schedule. Um, so I'm beginning I think I'm thinking of switching to Google Meet. I'm playing around with it a little bit because Zoom I think is a little bit of a ripoff. They're just charging a lot and they're not giving me a lot. Um, so
Professor,
I'm sorry.
uh, I think, I don't know, like we as students, we do have like unlimited Zoom. We can use it. Don't you guys have it or not, like professors or no?
You mean we have it on Brightspace?
So for Zoom, I think through our student account, we get like unlimited. Like we're not getting charged. For using the Zoom. So you say like it's charging a lot. I don't know. You're using Zoom.
There is a in Brightspace, you mean?
No, Zoom.
Yeah, but how would I get into it?
I think I was logged in through my like college account, and that's how I know
Yeah,
like
but
last
what which
year.
account? CUNY first or?
Yeah, CUNY first. Yeah,
Oh,
like yeah. So
okay, I'll look it up. So,
yeah, because I think we're getting that like as from the school. So
oh, you're right. So maybe I should do that
yeah.
because I don't like being ripped off because they just raised the money. No, Zoom, not Zoo.
Yeah.
Zoom for CUNY. Uh, okay.
It's like we have to log in through SSO, so the SSO will be CUNY and then it took us to the CUNY first.
Okay. I'll look at it. I'll try it right after this. Okay. Um, IT offers and staff helps communicate, collaborate with. Okay, great. So I'll try that. Then I'll just have to change because I've been paying for it my own, and then I just don't like it. They keep raising the price, and there's nothing extra. You know what I mean? Like why they just keep why they. I don't want AI and the new stuff they keep adding. Okay, so we have a while to the midterm. Okay, so okay. Uh, okay, thank you very much. I'll try seeing how that works. Um,
Not only that, we have other free accounts too. I didn't know that we have like free LinkedIn. I don't know, like Udemy, few classes, and Coursera. So there's a lot. That schools offer, but a lot of students they don't know about it. So
yeah, like I know other colleges, you get free New York Times. Yeah, like certain things you get, like you could get the online New York Times for free. Some colleges, I don't know if Queens has it. Um, anyhow, so. I think where I work, we also have Zoom somehow. So I've never, I don't know, I've never actually done it at work. I mean, I've joined meetings, but I guess I I don't know exactly how it works. They have Zoom and then they have Teams. I don't know. At work, we use Teams, so I'm used to that. Though I don't like Teams, so. They have any you used Microsoft Teams? I find it very confusing. Like someone could give you a message, but you don't know where it is, or you can't find it. Yeah, okay, that's my experience with Teams. It's like you got a message, and then once you looked at it, you can't find it. Like, where was that message I just saw a minute ago? And all these confusing things with um, channels, and yeah, I don't know. It's just the whole thing is too hard to follow. I like something simple. Anyhow, so today, let's start off with observer pattern, right? We haven't done that, right?
Professor, I have a question.
Yeah.
Today my date was for the presentation. Am I going to give it today or I have to reschedule it?
Well, you have to give it in person, so uh hey, you know what? You want to give it today?
Yeah, I'm ready if you
Yeah,
allow me.
sure. So present your screen and yeah, show it. We'll make
Okay,
exception to our general rule because everybody's online, so
okay,
could you have to request permission or
yeah.
uh hold on. Where's my Zoom thingy? Oh, I gotta go like that. Yeah, so uh yeah, so I think you just asked for permission, right?
Yes.
Okay, just realize you're being recorded. Okay, so should I stop sharing? Is that what you have to do?
Yeah, you have to stop sharing.
Okay, stop sharing. Oh, okay, now I see you. Okay.
I think you can see my screen.
Yeah, you can see it.
So, hello everyone. My name is Nusrat Al Fabiha and I'll be presenting today. So, my topic is 5 examples of bad database design and how to fix them. So, if we look the picture behind it, we can see it's very crowded and like seeing the picture, it shows that the data isn't fitting it all. Like there's too many people and very less spot. So today I'll explain 5 common database design problems and how to fix them. So at first, we have to know what is a database. So a database is an organized collection of relatable data, and it allows us to store data, get data quickly, update any information, or maintain the accuracy and consistency. And if our design is good, everything works smoothly, we can get data very easily. But if the design is bad, then the problem happens. We can't get the data, or like don't get the correct data and something like that. Yeah. So the first one is I got that is multiple values in one field. It's like we can see the picture that it's a very small room and it's very crowded. We have lots of courses in one. So the main problem becomes that if we put several phone numbers in one field, and if we are trying to get one phone number, or if we update one phone number, then the problem happens because we have to update it all. And if we want to search anything, like it doesn't give us a specific result, it gives us a lots of results which we don't need sometimes. So that's why if we add one value in one row, it's gonna give us like the answer we are looking for, that's easily. So the second one is repeating columns. So if we have like many courses in one columns, at one time we're gonna have a very big database. And if same thing, if we are searching for something, we have to go through everything, like because we are adding course 1, course 2, course 3, like the picture, and we will not get enough space for that. So if we just change it to, like if we transform this big database into two small database, we add with some foreign keys or primary keys, it's gonna be easier for us to find. So, oh, sorry. So for the better design, we have to separate the tables to make our searching query easier. The third one is data redundancy. So it's like if we store multiple data, if we store same data multiple times, and if we update one data, we have to update the second one. It will not update automatically. And that's why if we are looking for one data and if the data changed, the other data will not be changed at the same time. We have to do it manually. So for that, if we normalize the tables and store the data only once, it's gonna be easier. And if we're looking for the data and if we're updating it, we don't have to do it multiple times, and it will not like let us any problems. Like in the picture, we can see that the girl is saying she changed her name, but in other database, it's showing that she didn't. So the problem happens. And for the other fourth one, it's no primary key. So a primary key is the unique identifier of a database, and it identify separate rows like differently. So name, lots multiple people can have same name, but if we give name and ID together, it's gonna be a unique identity. So that can be our primary key. Also, our ID is a primary key. If we don't give the name, just ID, it's gonna be a primary key, and it's gonna be unique because we all have our different IDs. So if we don't have ID, and if we don't have a primary key, so lots like different people can have different people can have the same name. So like the picture, the professor is asking John answer the question, and there are two John in one class, and so the professor is confused like which John he should ask. But if we know the ID, he can just call the ID, and the specific John can answer the question. So if we put primary key, then we can find the exact database or exact value we want to know. So yeah, for better design, we have to add a primary key to our database. And last, storing derived data. It's mainly used for the calculations, I believe, because sometimes we use database and we calculate the whole value, like the total, manually. And the problem becomes when we are changing or updating any data in some previous rows, the total it's not gonna be changed because we were calculating it manually. So that's why if we use the calculation queries, then if we update or change any data, it's gonna be automatically changed, and we don't have to um, change it manually. So if we are finding the calculations, we don't have to like look for all the calculation if it's okay or not. So yeah,
It's
and
better we shouldn't store a something that can be calculated.
Yeah.
That's what you're saying,
Uh,
right?
and lastly, so if we like get the database, how if we get the good database, it's like organized and clear, then everyone is happy, like the picture. And to do that, we have to avoid redundancy, use primary keys, follow normalization, and design for scalability. And yeah, then we can get a good database and everyone will be happy.
What is scalability?
It's like, for me, I believe the calculations part for the database,
The what?
the calculation parts.
Uh, uh, n no, scalability means like to grow.
Oh,
You know,
I
that you could add more. The reason I asked is because it's part of, actually, it's part of software engineering that that program should be scalable in general, not just the database, but the program should be able to handle, growth, right? Like if you have a
oh
website, to be scalable means like it could handle like, you know, 20 times the amount of users it's using today, right? That's a scalable database. I mean,
so
scalable program or a database is also to be scalable means like, it could grow. It won't run out of room.
is it like if we add more data or add more users, it's gonna be like calculate or it's gonna grow automatically? Is it something like that,
It
Professor?
won't slow down. Yeah.
Okay.
Because it won't slow down when we add more users or more queries, right?
Yeah, got it.
It'll be fast.
Yeah,
It could grow. It could grow and still work properly, right? Because
got
like a lot of times you have websites, they have too much traffic, and then that's it. They're dead. Yeah. So okay, okay. Very good. I like your picture. You drew the pictures?
it. No, I got
Mm.
it from websites.
Okay, cool.
Thank
Okay.
you so much.
Okay, thank you. Uh, okay. So, okay, I'll share my screen. Anybody else want to present? You uploaded your presentation, by the way?
Yes,
Great.
I have uploaded it.
Great, thank you. So that way other people could review it. Okay. Anybody else want to present
Professor,
it? What?
my presentation is on, I think, like next date, but if you want, I can go for it.
Okay.
I mean, I hope I'm ready, but I'll try. Let's see.
Okay, so I'll stop sharing and let you share. You could share. Yeah, I'm not sharing.
Okay. Okay, so the topic I pick or chose
I
was
can see screen.
you don't see my screen?
No. Does anybody see it? No.
Does
You
anyone?
have to share it.
I can say it.
You can
Quantum
see a
computing
screen?
hardware.
Yeah, I can see his screen.
Wait, so why can't I? Let me just see. Why not Zoom work? But I don't see.
Let me stop and reshare. Okay, let me stop.
It says no, I'm sharing. You're looking at my screen. Now you try. I was
Okay.
screen sharing. Now I can see it. Yeah.
Okay. So let's see. Okay. So the topic I picked was quantum computing hardware. I mean, I was supposed to like do a presentation, like next day, but anyways, I'll try to do it. Okay. So one thing that I noticed in quantum computing hardware, there is a lot of myth that like people are saying like how the quantum computing are kept and the way that they're using. So I did some research and I made a lot of slides. So Professor, you can always stop me if I run out of time. So
Yeah, just try to keep it, 5 minutes.
okay, okay, let me just have a
You
time.
don't have to do everything. Yeah.
Okay. Let me just see if I have a timer. It's not much. Okay. So, so what is a quantum computing like hardware in general? Usually, like people, again, I mean, as I said, I mean, there's a lot of math, I mean, behind quantum computing hardware. Okay. So, I'll just, I mean, have a very quick introduction, and then I will talk about, like, I mean, some actual pictures that we already use, and then I'll have like a short conclusion about it. Okay. So, Richard Feynman, which is a giant, I mean, the quantum physicist, so he says that like he says that I think I can safely say that nobody understands quantum mechanics. And everybody he says that like okay, yeah, we are working on it, we are using it. I don't know, we're manipulating it, but we don't know like for sure like what exactly going on because they're like very very tiny, like the level of proton and like those particles. We don't know, but somehow we are using math I mean to manipulate it. Okay, so these are like some of the pictures, like I mean, the way that they're using like the coldest temperature, which we will, I mean, like in the second section, I'll get into it, like what exactly like each part, how they work and how they look. So they're using, I mean, like for the temperature, they're using the millikelvin, which is like almost 1 millikelvin is like almost equal to 0.001 Kelvin, which is very cool, like absolutely like I mean zero. So okay. Uh, so this is like the scikit or the Dirac notation, which shows that, like, let's say in classical computers, we have, okay, so we have like, I mean, regular bits, which is like either 0 or 1. But in quantum computing, we have qubits. Qubits show that, okay, the same, it could be at the same time, it could be in position 0 or position 1, which we call like in quantum computing, it's called qubit, which is like superposition. So in a way, like let's say this is the sign notation. Sign notation it equals to like a square a zero plus alpha zero plus beta one, which like when we want to get I mean the superposition, so we're getting the absolute value of the alpha. I mean like alpha square and beta square. So it gives us um, the superposition. So the probability that describes I mean two different component of the qubit. Okay, so another thing which is very important in quantum computing, imaginary number. Why do we use imaginary number? Because like let's say if you have it's very important like because normally we need like for like a classical computer we need like I mean the position like let's say the 2D dimension, right? I mean like the 0 and 1, like it's either in one position or another position. But imaginary number is a number that gives us like the third dimension. So that's also very important. Like I mean, without imaginary number, quantum computing would not be even possible. So it's a big, very important part of it. And then also it shows like the amplitude, like the phase control, which are like the two main component of quantum computing, which is shows the amplitude and also the phase of the control. Okay, so if I get it to the actual like what quantum computing is or quantum computing hardware is, so these are like some of the machines. Like this is like the entire like quantum computing, like the diagram or which is working. And this is like the actual chip that we have, like the Google Quantum processor that hold the qubits. And this is inside the chip. Again, these are very, very tiny. This is like, I mean, the macroscopic view of like what's going on like inside those micro, like super, like quantum computing chips inside. Like superconducting chips, so which has like resonators, it has qubits, and every one of them are working for I mean different purposes. Okay, so let's see. Okay, so like the picture that we have on the left, I don't know if I can uh, annotate or something. I don't know. Okay, so let's say I mean this picture that we have here, right? So this is like the dilution refrigerator. So actually, people are usually thinking that this is the actual quantum computing. So this is not. I mean, this is like the giant machine which helps like to maintain a certain uh, um like it's a refrigerator that makes the quantum computing chip to work there. So the quantum computing chips are actually a very tiny chip that you might have seen like the Whaley chip or other chips that were recently released. So these giant machines are usually there to give it like I mean the actual like the temperature so that those chip can work or be able I mean to I mean operate. Okay, now let's see. Trying to go to the next slide. I'm going to. Okay. Okay, so these are like, I mean, the parts that we have like inside the quantum chip. Again, I mean, these are like microscopic views. So first we have qubit. qubit are like the tiny loops. I mean, like in the first picture that we have, these are like the qubit, which we say that like every quantum computing, they do have like different qubit sizes, which is equal, like let's say somewhere like, I mean, two or four or 20 or 100, right? And that means that their capability is like, let's say if it's like 23 qubits, it means that they could be in the 23 superposition at the same time, which shows like, I mean, the higher the number is, I mean, the better the processor is. Okay, so then we have like resonators. So the resonators are the line that sends the signal, I mean, to the qubit. Like let's say it's getting, I mean, the signals. So through resonators, you're sending those lines or signals to the qubits and read it. And then we have a coupler, which is like this picture C. So those are like the small parts that connects two qubits together. So we might have, as you said, let's say we have a quantum chip of like 20 qubits. So these couplers, I mean, it makes those qubits so that they could connect. I mean, they're connected to each other. I mean, through these ones. And then we have microwave lining. Microwave lining, or the metal path that brings, I mean, control pulses, I mean, to qubits. So we have like different, I mean, control pulses. Like there are like different way that, I mean, that we can, I mean, send signals or electricity or whatever, I mean, so that we manipulate, I mean, those qubits and work with them. Okay, and then we have ground plates, I mean, that make that we are the gold plate, I mean, that keep the chips like stable and quiet. And then we have like substrates, which are also in the picture that we can see. So those are the base material, or silicon or sapphire, that the chips can sit on it. Okay, so let's see. Okay. Okay, so again, okay, so this is like, I mean, again, as I said, like we have like these giant machine, which like everyone thinks that maybe this is the actual, I mean, quantum chip, but it's not. This is actually the dilution. It's called like dilution refrigerator, which has like a few parts. So the first part, I mean, like we see those plates that are circling around, right? Those are called, I mean, the cold plates, which are like, I mean, so the lower it gets, the colder it gets. I mean, so those are the plates. And then we have like wiring. We see like those gold wiring. These are like 10 cables that sends signals into the chip. And then we have the mixing chamber. The mixing chambers are, I mean, the coldest point where the chips sits. And then we have the outer layer structure that which makes, I mean, like covers, I mean, these, I mean, refrigerators. Okay, so
Why does he have to be so cold?
okay, so some of this quantum computing chips, it has to, like, in order to work, I mean, like it has to be in a certain degree. Like let's say the some of these quantum chips has to be in the 0.001 like Kelvin, which is like very cold, like absolutely like close to zero, so that they don't lose electricity. Like let's say when the signal comes, so they can, I mean, like it cannot be. I don't know what's the word for it. I mean, like let's say it cannot be like I forgot the word, but so that it stays there. It does not, I mean, get deflected. But it's only for this one chip. I mean, that's one of the things that I was thinking, that okay, every one of them has to be like this. I mean, it has to keep the temperature. But there are like other chips that I have in this presentation that it can definitely work in a normal temperature as well, which a lot of people even think that it really has to be in this absolute zero temperature so that they can work. But no, there are other chips that are working and companies are working on it. It doesn't have to be like this cold, but then they have to have like, I mean, their own like places. Like let's say this is like a part, I mean, the thing that I wanted to mention. So do all types of the qubit chips need to be cooled down to about like 0.001 Kelvin? No, they don't have to. And there are like a lot of examples that we might have. Okay, so these are like some of the examples that I have. Like there are real qubit chips in the world that we have it right now. So this is, I mean, one of the, I think this is the Velo chip that the Google releases, I think in 2019 or sometime. And this is also the Google chip, like superconducting chip, Sycamore, which is actually there right now. They're using it. And then we have, this is the IBM chip that they're using. It has like 127 qubits. And also, so different companies, they have Ionic. This is another company which is like trapping ion, I mean, to do the calculation. So this is another chip that are currently there. And also like D-Wave, this is another chip that which they claim that they have the advantage of, I mean, like a chip over 5,000 qubits and designated for massive optimization. I don't know like how true that is, but and there is another thing as well. I mean, like most of these chips that they're saying that they're doing all these calculation for some reason, like, I mean, no one has seen, I mean, those chips yet. So, I mean, like, actually, they haven't seen it. It's a very, like, classified thing. Okay, let me see. Okay. Okay, this is another example like Microsoft, which is also like, I mean, they have it, but it's still in the, uh, in research phase that they're working on it. So these are like, I mean, Rigidity, there is another superconducting chip that they have it, so which has like almost 84 plus, qubits. And then this is another chip that we have like a Quantinuum, it's like another company that they have it. So this is like Alibaba, a Chinese company that they also like made, I mean, this chip as well. And this is like another company, Baidu is also a Chinese company that they also have like, I mean, these qubits, I mean, they made it, they have it. Okay, so how qubits actually like work? Okay, so superconducting almost zero electrical resistance at very low temperature. Okay, so a tiny loop made a superconducting material, a very small current flow in that loop. That current can be a low energy state, high energy state, or both superconducting chip. So these energy state are qubits. The chip is just hardware that holds it. So in a way, it says like the energy is like flowing, looping around. I mean, in those chips to do the calculation. So that's actually how it like the superconducting chips. I mean, they're working. Oh my- Okay, so how different companies, I mean, controlling their okay, they're qubits. So there are like different ways. I mean, like okay, so different companies realize, okay, so some companies, like let's say they're using superconducting chips with tiny currents in a loop, or some other like trap ion, they're using trap ion, or some are using like photonic systems. So these are like different ways that they're like manipulating their superconducting to use it. Okay, and then like normally we have like spin up and spin down and superconducting. Like let's say in a way that we have that one thing like in a few like let's say in different position, like it could be in 0 and 1 at the same time, the possibility, but it's leaning in towards one or other one. That's how we are getting. Professor, I can go on, but I think I'm almost 12 minutes.
Yeah, yeah, it's very interesting, but it's hard
Yeah,
to understand, like you said at the beginning,
yeah, I
how it
mean,
could be true and false at the same time.
yeah,
Okay, thank you very much.
you're welcome. I did submit, I mean, the presentation, so I really worked on this one and I love this topic very, very well. So so hopefully, I mean, like, I mean, they will like it too.
Yeah,
Yeah.
okay, very interesting. Thank you.
Okay.
Okay, so today we're going to do the observer pattern. Um, so I'm going to use an example, and then we'll see where we're going to go from there. Okay, so but at least I'd like to do the if you remember, um, last week I ended off with the showing how in Microsoft uses the observer pattern. Um, Today, I want to do another example um, as opposed in Java, as opposed to the way that they do it. Which I think once you see this, you'll see what I mean. Okay, so let's try the observer pattern. Okay, so it's a form of the strategy pattern, so it's not going to be crazy new, but it's you'll see. So let's say, for example, we have a new project called um, it's called Spring. So let's imagine, for example, let's use a let's have a stock market. Okay, so in order for you to have a stock market, let's just first we need some stock. So let's I'll make a stock, and let's say I'll give it a name and a price. Okay, and yeah, let's just make this public. I mean, just for simplicity, I'm just gonna make this public. Sorry, I used the wrong lower p. Um, and then we'll have price, and then Okay, so a stock could have a name and a price, and we'll just keep it really simple. And then what I'm going to do is when you create the stock, you set both of them so that we're going to generate a constructor, which is going to set both of these, and that will be it. Okay. Again, I know I told you this should really be private, but you know what? Let's make this private. And then let's just create two getters. Why should I teach you the wrong way to do things? And then we should do a generate a two getters um, for these. Okay. So we just we call get price and get name in order to I'll just put this at the bottom. And this is how you would read it. Okay. Then we have a stock market and a stock market is going to have um, let's say a list of stocks. So we could have a list of stocks and these are my stocks. And then um, Alt Enter. Let me think about that. Alt Enter. Come on. So this is going to be a new, and we'll make this an array list. Okay. Does anybody know what I just did now? What is this over here? Does anybody know?
Did we create an instance of?
Yeah, so what is this over here? This is the left side is called this is really actually um, a interface. So it's not really a actual type of class. Okay. So that's why on the left side, so don't get confused. The left side it's a list, but it's on the right side is a concrete class. On the left side is a non-concrete. Okay, it's a um, it's a uh, what was the word for non-con? You have either concrete or you could have wait a second, what's it called? A not virtual, a um what's it called? It's a abstract type, right? So it's not a concrete, it's abstract. Okay, so interface is like an abstract type, and the right side is the concrete. Anyhow, but the point is we have a list of stocks, okay? And then we just want to add two methods, buy and sell. So I'll make these public. So if you buy, um, we're going to add, you buy a stock. So we're just going to do very simple. We're going to say stocks dot add the stock, and then sell. Oh, this should be void. If we sell, we're gonna just remove it. Okay, very simple. Okay. So far, it's very simple, right? We just do, okay. So we have very simple code, and we're just going to Um, this should probably be private over here, just to be, okay. So, so now let's make it a little more complicated. So let's say, for example, someone wants to know when the stocks are, no, let's say I have something else. Say I have something called a, um, let's say the government. So, the federal, I think it's called the Federal Trade Commission, FTC, right? So they want to be notified, right, when a stock is going to be sold or bought. Okay, so I think it's called FTC. Does anybody know who governs which government? Maybe it's a different one. Which government? Does anybody know which government agency is in charge of um, agency is in charge of stock market, sales, stocks and bonds, and that would be SEC. Oops, I was wrong. Okay, so go back here. Let's change it to SEC, Securities and Exchange Commission. Okay, so let's rename it to be SEC, and then it's going to want us to rename the file in a second. And then so they want to be notified whenever someone buys or sells stocks, right? So there's a notify method, and they want to know, um, why is it giving me red? Okay. So we're going to not be notified when there's a stock being sold or bought. So we'll just do a Boolean buy. Okay, um so when it we just have to change the name of the file. Okay. So so basically when the we're gonna say um we're gonna do S out, we're gonna say that stock um and we'll do, let's say, stock got get name plus dot get name, um and then we'll do plus, then we'll say, but if it's by, then we're going to return the word uh, buying. Otherwise, we're going to return the word selling. Yeah, it should say. And then buying or selling. Probably put a space here, and then the space after. Uh, and then we should do uh, plus. Some languages get confused, so we should probably just put this in a like that, and then plus. Um, so we're either buying or selling the stock. That's good enough. Okay, so I'll just say the SEC. SEC is notified that we're buying or selling the stock. Okay. And the stock over here is going to be, here, so you can see it. Okay. Okay, so now we need to put inside here a um we have to do a reference to a SEC, right? So we'll do SEC equals to new SEC. And now every time we buy a stock, we're going to do SEC dot notify stock, and over here we're buying, so this would be true. And then over here we would be selling, right? So this would be false. Okay. So so for example in Maine, right? So if we create our stock market, this is how it would look. So we would do a stock market. Stock market equals to new stock market. And then we would do like something like stock market dot buy, and then new stock. And then we would pass in the name, let's say IBM, and then we would pass in the price, which would be like $123, right? So if we do this, let's see what happens. So we should be, so when we buy the stock, we should be notified, SEC should be notified, okay? So that's how our code works, right? So we could run over here, and when we buy the stock, okay, so right, so it says we bought IBM, and then if we want to sell it, it would also, um, well, it doesn't make sense really so much, but because it's a different object. Um, so this is not going so I would probably want to do something like stock IBM equals to new stock. And then I would just buy and sell it. Because I don't know if the code's going to blow up. So IBM, and then we could sell IBM. Okay, so over here, we run the code. We see we could buy and sell it. Okay. Okay, good. So we're buying and selling IBM. Okay. Now, let's say for example, we have a another person, another entity that's interested in what's going on in the stock market. So let's do, for example, a why is it doing that? Um, yeah, so let's go back to our stock market, and let's say, for example, we have, let's say, the Wall Street Journal, right? So the Wall Street Journal also wants to know when the stock is being, or let's say Bloomberg. Okay, so Bloom, is this how it's spelled? I think this is how it's spelled, right? Bloomberg? Yeah. So Bloomberg wants to know when the stock be notified also, right? So let's say Bloomberg wants to, let's just copy the same code as SEC. They also want to be notified, right? So we'll just copy this code over here. And then we put this here and we'll just change this to Bloomberg. And now Bloomberg is going to be notified when um, when the stock is bought and sold. But now, what do we have to do? We have to, one second. Okay, let's see what's calling. And then, I apologize. And then over here, we would do Bloomberg. Oops. Where's my stock market? I would have to copy this code over here and do the same thing. So I would have to do Bloomberg, or is it Bloomberg? Um, Bloomberg equals to new Bloomberg. And then over here would be, so now I would have to notify two people, right? Okay. Um, okay, so um, okay, so now now if we go back to main, so we have two people notified, right? So so this code works, except what would you say is wrong with this code? And as this code, it works correctly, right? When we buy a stock, we sell a stock, it's working correctly, right? Everybody's being notified. But what's the problem? What look at stock market. What looks wrong? Does anybody have an opinion? Anybody's noticed something that's going on over here? What are we doing that might be wrong?
We do have a void function for the buy, but we don't have it for the sell.
Say again?
Oh, we do have it. No, never mind.
Right, but look what's happening. Every time we add a let's say a listener or someone that wants to be notified, we have to keep on changing our code, right? This is kind of that means every time we either want to, let's say we want to remove Bloomberg and we want to replace it, or we want to add Goldman Sachs, right? What are we going to have to do? Every time we add a listener, we have to modify the buy code and the sell code, right? Well, right, this is what does this violate? So this code needs to be updated every now I'm not saying it's brain surgery to fix this problem, but let me hear your ideas. Every time we add or remove a um a um a observer or listener, or if we want to could call it a listener. Okay. So every time something happens, we have to actually physically change this stock market code, right? And it's kind of it's not pretty, right? Look at this. Every time, let's say we have 10 listeners, we're going to have to add 10 things over here, right? What would be a better way to do it? Anybody have an idea? A suggestion? Man, you guys are smart people. How would you solve this? Okay, so in order to solve it, we'll do the observer pattern. And what the observer pattern does is like this. The observer pattern says, let's make a list of all these listeners. So rather than changing this method every single time I add a listener or remove a listener, we'll just keep them in a list. So instead of having SEC over here, Bloomberg over here, right, I'll just create a list of listeners. Okay? So let's create a new class called, um, I'll just copy this code and we're going to create, let me just make sure I copied it. So Control A, Control C, and then I'm going to create a new class called Stock Market New. Okay, and over here, I'm going to make a little bit different. So I'm going to get rid of this. And in Stock Market New, I have too many of these, I guess. Okay, so over here, what I'm going to do is I'm going to instead, in other words, do you remember how do we how do if we have different types, we have Bloomberg and SEC, right? Do they have anything in common? Is there anything that makes them, besides the fact they're observers, right? What do they have in common? Well, if you look at them, you notice they both have the exact same method. In other words, even though they might be totally different objects, right? But they do have one thing in common. They both have the same notify method. And and do you remember that if we have an if we how do we take things that are not exactly the same but have something in common, how do we group them together? Do you remember how we do that? What do we do? We create a what do we do? Come on, you remember this, don't you? Someone volunteer. Well, we create a interface, right? So we'll create an interface called observer. And now, once we do that, in our observer class I'm sorry, is an interface, not a class, is going to have a method called notify with these arguments. And both Bloomberg and SEC are going to implement this interface. Well, they actually do already, right? So, but now we could treat them the same, right? Because they both they might be different objects, but they both have the same method, notify. So now going back to our stock market new, what we could do is we could we get rid of SEC and Bloomberg. Instead, we could have a list of observers. Sorry, what did I just do? What is that? We could have a list of observers. So observer and call these observers. And now, rather than now rather than hard coding different concrete types, right? We could we could notify all the observers in our list. So we could say, so we could, for example, we could go to a for loop. So I could say for every observer O in observers, we could do O dot notify and we could send it the stock and we could send it we were buying, so it would be true. And we could do the same thing for sell. So every time we sell a stock, we're going to notify all the observers that something was sold. Okay. And now all we have to do is add code, a very simple method called add observer and remove observer. So we have to add two methods to update our list. So we could so actually this is good. So now we could have public add observer and then what this is going to take is a observer and O and it's just going to do observers dot add O and this is going to should be void and then we're going to do remove observer um, and this is going to remove. Okay, so now going back, so let's see how this is all going to work. So going back to main, we're going to, right now, let's just comment this out and let's try again. Okay, so, so let's say we're going to do stock market new. Oops. And it's going to do new stock market new. And now what we're going to do is we're going to add over here our listeners. So I'm sorry, our observers. So we're going to add, for example, new Bloomberg as right. And the reason why we could add Bloomberg is because Bloomberg is a observer. And the reason it's observer is because Bloomberg has this notify method. And we could also add SEC, right? I'm sorry, where we have domain. So we could also add SEC as a observer. And now we'll have the exact same code as before, but we don't have to keep on changing the stock market anymore, right? In other words, this this object isn't going to change anymore, right? Because if we have if we have no observers, this won't do anything. If we have 20 observers, they'll do the same code. So this code is not going to change anymore. So this code is much nicer than this code, right? This code over here, we have to keep on adding, we have to keep on changing it every time we added a listener or every time we remove somebody, right? Over here, it's much more flexible, right? We could just run the same code, we'll get the same results, but we don't have to change the code every time we add a new type of listener, right? So for example, right, so over here we're the exact same messages, right? But we could actually, let's say I could, for example, remove observer, right? I need the same one. So let's do um, observer O equals to new Bloom, whatever, new Bloomberg, and then let me just add a two observers. So the reason why is because I need a instance of it. Can't just have to keep track of it. So let's say about two observers. O2 equals to new uh, SEC. Then over here, I could add initially, I could, oops, I could add O1 and O2. And then later on, I could remove it. And then, so over here, for example, when I bought IBM, right? So they were both notified, right? But let's say I want to remove SEC, and then I want to buy, let's say I'll make a new stock called Microsoft or Google, I'll call it. So new stock is Google. Google. And let's say it sells for, I don't know, $98. And then I'm going um, to buy, let's say, Google. So now when I buy Google, what did I just do? I did debug. I don't want to debug. Okay. So now when I'm buying Google, wait a second, I removed. Oh, SEC, remove observer. Oh, no, it can't be SEC. It has to be O2. Okay, O2. So now I got rid of the SEC. So now only one person is going to be, uh, whoa, how could, yeah, the two, oh, yeah, this should be good. Okay, so now when I run it, so um, only I only have one observer uh, noticing that I bought um, that I bought Google, right? Because I removed two, which was SEC. Okay, so that's basically the idea of the observer pattern, which is basically so basically the observer pattern. So allows us to add and remove um, observers without modifying existing code, right? So we don't have to change stock market anymore when we want to add a new observer or remove one, right? So this is which principle is this? The object or principle of, what is this called? When we don't have to change code, we just add code. Remember what it's called? Open, closed principle, right? Or it's open for extension and it's closed for modification. For modification. Okay, so we don't have to, which means in this, for example, over here, we don't have to change this. We don't have to change the stock market every time we add a new observer, right? It's going to be the same code again and again. All we have to do is create a new class that implements observer, right? And then we're good to go, right? So we're open for extension, but we're closed for modification. Okay? So that's the idea. We're open we're open for extension, meaning we could add more code, but we're closed for changing. We're not changing existing objects, right? Does this make sense? Anybody have any questions? Okay. Hope it wasn't that complicated. Okay, so I'll see you guys on Thursday. Okay, in person, hopefully. Okay. Okay, so I'll see you. Have a good night.
Bye. Have a good night.
Okay, good night.